And welcome everybody to session 6, or lesson 6 that is. It's great to be back with you. Once we've taken a look at configuring external and internal BGP neighborships, and we now understand how they act a little bit differently, in that when we send updates to an external BGP neighbor, we prepend our autonomous system. If we're sending routes inside of our own AS, we don't add any additional ASs to the current AS path. We also identified that when a external neighbor sends another external neighbor an update, that same AS, the same next hop attribute, is carried with it as it gets sent inbound to an internal neighbor. So if you want reachability, most of the time your edge routers running external and internal BGP will want to change or set that next hop to themselves for the benefit of the next internal neighbor. So on our journey as far as where we are, we're going to focus on internal BGP and how that operates, and also how to set up some fault tolerance. See, there's a couple of issues that we deserve to be aware of with internal BGP, and one of those is the rule of split horizon for BGP. Let me bring you over to my screen, and we'll go ahead and go through that right now together. And I'm picking the right screen to show. That will be helpful. And as always, you've got those controls in the bottom left-hand corner that can do this full screen or not so much full screen. So here's the rub, if you will, with internal BGP. There is a rule called split horizon for BGP, and it goes something like this. I get up my pen. If an update, so we have an internal neighborship from R5 and R6, that's still present. If an update is being sent from R8 to R6, that would be an iBGP update. We're all good with that. And then as that update is sent from R6 to R5, that would be considered an internal BGP update from the perspective of R6 and R5. Let's add another session. Let's say that R5 also has an internal BGP neighborship with R3. Well, that's well and good, but the problem with internal BGP, by default, it says this. If I, speaking about R5 at the moment, if I receive an internal BGP update from anyone, I am not going to send that to any of my other internal BGP neighbors. That's the split horizon rule for internal BGP. So how do you get around that? Well, one option is not get around it. So what we could do is we could just simply do this. We could create a full mesh. So we could say, for example, that R6 is going to peer with R3 with iBGP, and we'd have to have R6 peer with R7. So now when updates come in from R8 to R6, R6 would send those to R3, R5, and R7, and that's okay. So now they would know. Oh, what about R4? He would need to know one too. So we're going to need another BGP session, internal BGP right there. So that's all well and good. That would cover everybody if we're taking a look at updates that come in from R8 to R6. But what about this connection over here from R1 to R3? Well, because R3 learns it via external BGP, he's going to send that update to his neighbor R6, but R6 isn't going to forward that to anybody else because R6 now learns that route through internal BGP. So we would also need to set up a neighborship from R3 to R4, so R4 gets the route, from R3 to R5, so R5 gets the update, and from R3 to R7, so R7 gets the update. I think that's it. Well, it's okay, fine and good, until we do an external neighborship between R9 and R7. Now, when an update comes in, same story, different day. An update comes in via external BGP. R7 sends it to all of its internal BGP neighbors, but it's not peering with R5, and it's not peering with R4. So to make that all work, we would have to actually build another connection there, and another connection there, and what they call this is a full mesh, which is what it is. So with 5 routers, let's count how many internal BGP sessions would be required. There's 1, and there's 2. I'm going to go all the way around the horn. 3, and 4, and let's do 5, there's 6, there's 7, there's 8, there's 9, and I'm missing one. have I not identified? Oh, and this one here. I've got that one, 2, 5, 6. Oh, there's no relationship from R4 to R5. So if I had a there's my missing connection. If I had an external BGP neighborship like that, R5 would get it actually, because R4 would learn it via external and send it to R5. But if we wanted to configure a full mesh, there's our 10th network, by the way, we would have to have 10 logical internal BGP sessions. So the formula for that is n times n minus 1 divided by 2. So for a full mesh, that's the formula. So how many sessions would it take we have 5 routers, so that'd be 5 times 4 divided by 2. So 5 times 4 is 20, divided by 2 equals 10. And that's our 10 internal BGP sessions. Now, I am not going to have you sit here and watch me do all 10 sessions, because that's a lot of work. I mean, once you've configured 1 or 2, which we will definitely do, you've seen it. But in the order to do a full mesh, it's going to take that many sessions. So R7 is going to have 4 connections, and R6, every router in a 5-router autonomous system is going to have 4 additional internal BGP connections to the other devices. So what a pain that is. There ought to be some way to fix that, and there is, and we can use 2 methods to solve that. One is we can go ahead and we can use something called route reflectors, so we don't have to have a full mesh of internal BGP. And the second is we could use confederations, both coming up as lessons. But the actual reason for the full mesh is the split horizon rule. When a route is learned via external BGP, we send it to our internal BGP neighbors, but if we are a router and learn a route via internal BGP, we do not, again, regurgitate that to send it out to any other additional internal BGP neighbors. We won't send it back to the person who sent it to us, that's a given, but we also won't send it off to any other internal BGP neighbors. That's the nature, if you will, of internal BGP. So here's our full mesh with 1, 2, 3, 4, 5, 6, 7, 8, 9 routers. That'd be 9 minus 1 times 9 divided by 2. That's a whole bunch. So I don't want to get out my calculator, but you can see if you had 100 routers, that's 4,950 BGP sessions that you'd have to set up. So each BGP session is a bidirectional TCP session between the 2 peers. So again, that's more than we'd ever want to deal with in a real sense, because there's just a lot of overhead with managing all those sessions. But by default, if we don't change some of the rules, that's what we'd have to do internally. So another problem that we're going to face is the issue of setting up fault tolerance. So let's go back to our diagram for a moment. And right here, check this out, everybody. Right here, let's say that, wow, that's a lot of drawing, Keith. Let's say we're peering between R7 and R4, and we're using that interface right there. So that network is the 10.47.0.0/24 network. So this is .4 right there. And if R7 is peering to the IP address of 10.47.0.4, what happens when this interface fails? If that interface fails, and we no longer have reachability to that IP address because the interface is down, our BGP session between R7 and R4, it's over. If we have more than one physical connection, I'm talking about just IP connectivity, TCP connectivity, if we use the loopback interface of 4.4.4.4, and that was reachable because of the IGP we're using, like OSPF, R7 could peer to that loopback interface, and then even if a single interface fails, we still have fault tolerance. We still have our connection because we have more than one path that would lead us to get to 4.4.4.4. So using loopback, first of all, the IGP full mesh is not a realistic thing to implement. And secondly, by using a loopback interface, we can have some fault tolerance built into our actual design. So a couple things that come to mind before we actually go configure this. One is if we do set up our neighborships based on a loopback interface, we have the problem we talked about in session number, I think it was the previous session or 2 ago, where I'm trying to peer with the loopback interface, but I'm actually sending the actual request sourcing them from my physical interface. So probably the second biggest thing that people forget to do is when you are when you're peering with the neighbor's loopback, you want to go ahead and specify update source for that neighbor session. Otherwise, if we go back to our diagram, if I don't, that's not our diagram, this is our diagram. Otherwise, R7, if R7 is trained to peer with 4.4.4.4, and R4 is configured to peer with 7.7.7.7, by default, both those devices are sourcing their BGP sessions from the closest interface based on the routing table. So they, R7, whichever interface he is going to use to actually reach the 444 network, by default, that's going to be his source. So by using the update source command, you're simply telling it to source the BGP session from your loopback. That way when the request goes from R7 to R4, the source looks like 777. If there's a neighbor statement on R4 that says, I want to be a neighbor with 777, life is good and they can establish the BGP session, go to establish state. So that's how those pieces are flying together as well. Update source for that. So what we're going to do right now in the demonstration is I'm going to walk you through both of those options. I'm going to walk you through setting up update source and doing it with the loopbacks, and then in the next sections we'll take a look at not having to do a full mesh. So as far as our network goes, let's bring this up again. We're not going to do a full mesh. I'm going to do just a partial mesh. In fact, I may just do R6 and R5 again because we're going to rip it all out here in a few minutes to do route reflectors. So let me do File and Open, and let me bring in this diagram in a non-messed up state. Alright, so there it is. So we have an internal BGP neighborship right here between R5 and R6, but it's focused on the actual 10.0.0, I'm sorry, the 1056 addresses. So what we're going to do is we're going to peer R6 and R5, but instead of using the physical interfaces, we'll use the loopbacks. What is important to remember? You need to have reachability to these loopbacks. If they aren't being advertised by an IGP or static routes or some other way, your BGP is not going to be too happy. And you also need to source them from the correct IP address inside of your BGP config. So let's jump on R6 and let's set up R6 first using update source loopback 0. So we'll jump over here to our good friend Mr. Putty Connection Manager, who is here somewhere, and we'll go to R6, make sure we're on the right device. Just to verify, I'll just show IP BGP summary, and we've got our beautiful neighborship, but we're peering with this guy as the IP address of the neighbor. That's not his router ID. That just happens to be the IP address we're peering to. If we wanted to find out that neighbor's router ID, we could just show IP BGP neighbor, and it would show us the router ID, whatever it's currently set to. So on router 6, we'll go into router BGP autonomous system 3, and we're going to do show IP, do show run, and we'll say section router BGP, just so we can see exactly what's there and then make the modifications. So I'm going to say no, and I'm going to take out this neighbor statement right here. So now that's gone. Now what that also did, this is important to know, if I do a show run including BGP again, it not only got rid of the neighbor statement, but it also got rid of the next hop self. We're still going to need that, so as we learn external routes, we go ahead and change the next hop. So now that I'm changing it, I need to make sure I put the next hop self back into the mix. So here we're going to say neighbor, and my neighbor is going to be 5.5.5.5, and his AS is going to be 3. I'm going to say update source loopback 0. That will have me sending my my BGP initiation messages, my opens and so forth, with the details of the source IP address that I want to use. And then I'm also going to use, for that neighbor, next hop self. Okay, now what's happening now is that we've added this neighbor. We're making these connection requests, these opens to him, but we're sourcing it from 5555. As a result, because R5 doesn't have a neighbor statement that says I want to be neighbors with 555, that connection won't work. However, when we have a request, actually, yeah, the request from the other side is coming in also. It's coming in from the serial interface. We don't have a neighbor statement for that, so we need to fix both sides. Let's go fix R5. And let's do a config T and router BGP3. And we'll take out the old neighbor statement. And we'll simply add the new neighbor statement. Neighbor of 6.6.6.6 remote AS3. Now, I'll tell you what we can do here. Now, when requests are going to be sent to this neighbor, we are not going to source them from our, if I just pressed enter until I do update source, we're going to source this from our 10 interface. So request from R5 going to R6, R6 is going to say, what? You're trying to be a neighbor with me? Your IP address is 10? I don't have a neighbor statement that matches you. But R6 does have a neighbor statement that points to R5, and it is using the correct source IP address. So in that case, if I just press enter and we let this thing sit, R6 will be the client because it will make its request to 555, and because it has a source address of 666 and that matches the neighbor statement, we're up. So if we do a do show TCP brief, what we should see here is we should see that R5 is the server and R6 initiated the connection to us using this high numbered port. Now, just for good, correct, clean configuration, we are going to put update source on R5 as well so that he will have the ability to initiate a session. So neighbor 666, and we'll say update source loopback 0. There we have it. Okay, so what we could do is we could do that on all of our internal BGP speakers and have a party. So there you have it. Let's do one more. I'm not going to do a full mesh, but I will do a few just to demonstrate this. So if I do show IP BGP summary, you'll notice that I have a neighbor, and because I'm connecting to 6666, that is the IP address I'm using. His router ID also happens to be 6666. And if I do show IP BGP, because he's modifying his next hop should equal the IP address I'm using for him as a neighbor as well. So there's my routes. They're all usable. I've got one that's no good, and that's because there's a better route via the directly connected network, hence the rib failure. Let's do one more. Let's go ahead and do one more. In the live class, if you would be so kind as to tell me which one you'd like to do. Let's just do one more internal BGP connection. We could do R5 to R3, R4 to R5, R5 to R7. It really doesn't matter. The first person who chats in a recommendation will go with that. So mark, get set, chat. Now, I know some of you are saying, well, where do I chat in? In the in your console, you have the option for full screen or not full screen. If you deselect full screen, you'll have the window that comes in. All right, Tony was first to the draw. Thanks, Tony. Let's go ahead and do R7. So we'll make a nice little BGP neighborship down to R7. And for everybody else, you can go ahead and click on full screen again and go back if you'd like. So we're going to make the connection down to R7. R7 has a loopback. We're going to make sure that we have reachability to that 777 from R5. So let's go configure both of those. We'll start on R5. Okay, here from R5, we're going to do ping of 7777. Make sure it's in the routing table. And we're going to source that from our loopback 0 just to make sure we have connectivity, and we do. So we'll do a neighbor, and the neighbor is going to be 7777, and he's going to be remote AS along with us, remote AS3, and we're going to say neighbor update source loopback 0. Now that neighbor is not going to come up really quick because it's not running BGP yet, so we'll need to fix that. But that's it. We specify the neighbor and we specify the update source loopback 0. With internal BGP, the TTL for the updates and so forth are set 255 by default as they begin. So there's no issue with how many hops away, other than more than 255, for internal BGP. So we'll go to R7, do a show IP protocols on R7. We're just running internal BGP, we're just running OSPF, and we'll do a router BGP, and it's going to be 3 for autonomous system 3. We'll hard code the router ID, and we'll set that to 7777, so we don't have to later go back and mess with any sessions if we change it. And then we'll put a neighbor statement in for 5555, and he's in remote AS3, and we're going to say neighbor 555 update source loopback 0. And we just wait a few seconds, debug IP BGP, and that'll catch at least the tail end of the open confirm and the establish state, unless it's already up. I see nothing, unless I missed it. Show IP BGP summary. Active state. Oh, there we go. All right. So it went from it went from idle to connect. Then we had the capabilities exchange, and then it went from open sent to open confirm. So basically it agreed with all the options the other guy said, and then we went from open confirm to established. So great, we've got our neighborship up. So we do a show IP BGP. Ah, there's no routes. Dang, 0. Well, maybe we need to wait. You know, sometimes BGP takes a few minutes. How long do you want to wait? I'm saying we wait like 0 more seconds, because let's take a look at the topology and what we just built. And by the way, it's a great recommendation of R7. It could have happened with anyone. Updates that are coming in, and I'll get my pen out here, updates that are being sent from R8 are being advertised to R5, and because R5 learned those updates via internal BGP, it's not going to advertise them to another internal BGP neighbor. So that's the reason that R7 is going hungry. We can verify that on R5 if we go back there. You can actually say, hey, what are you sending to our good buddy R7? So on R5 we can do a little trick like this. Show IP BGP neighbor advertised routes. And that's going to show us all the routes that R5 is sending to R7. Now what R7 does with those is another story, but we're not sending him anything. And that's because all the routes that we've learned show IP BGP. That's because all the routes we've learned. Take a look at the I. Now the I on this side is the actual status codes. So the I here, just to the, let me see if I can just highlight just that character. Come on, just I. There we go. That I right there is the status code, which means I learned this from an internal BGP neighbor. So anytime by default this router learns from an internal BGP neighbor, he is not going to send those prefixes, those advertisements, to another by default BGP neighbor. So that's it. Let me just take a look at my notes and verify I covered everything I intended to. So as a review, we took a look at using loopbacks as a fault-tolerant mechanism. However, make sure you include update source on your BGP sessions. Otherwise, if you don't do it on at least one of them, they won't set up. And secondly, we also took a look at the split horizon rule for BGP, which is that if I learn a route via internal BGP, I'm not supposed to, by default, send that route to another one. We also took a look at the formula for how many possible peerings we'd have to have. So if you've got 10 routers, if you plug in the number, or 5 routers, if you plug in the formula, you're going to have 10 TCP internal BGP sessions. And if you have 1,000 routers, that's half a million peerings. That's not going to happen. So we're going to use two techniques in the next two lessons. The next one is route reflectors to avoid having to do a full mesh. And then we'll take a look at, in lesson 8, at confederations, yet another way to avoid having to do full mesh of internal BGP. And that's it for this session. I'll see you in the next round.